problem number 1, which states 6.525 divided by 3.5. Would you rather deal with it this way, or would you like to, through the function of multiplying by 10, move the decimal? What would you like to do? Grace? Move the decimal. And the way we do that is to multiply both sides by the same factor. Each side gets treated fairly so that the answer stays the same. So I'm going to end up with 65.25, which kind of makes sense, right? What's 10 times bigger than $6.50? $65, right? So we think that's right on. And then 3.5 times 10 becomes, well,
35.
10 times greater than 3.5 is 35. So now let's revisit this problem as if it's 65.25 divided by 35. And first things first, what are we going to do absolutely first? What do you want to do first? Maggie?
Do you want to see if 35 goes into 6?
You want to shmestimate. You want to estimate, right? You want to estimate first. So you make a little cloud off to the side. And about how many times do you think 35 is going to fit into 65? You think it's going to get in there twice?
Yeah.
Almost twice?
Almost.
So could we say that our answer is going to be a little bit less than 2?
Yeah.
Okay, so we'll leave that as our estimate. How many times I'm going to use standard algorithm, you guys. How many times does 35 fit into 6? Listen to the questions I'm asking, because these are literally the questions I want you to be modeling when you're trying to do a division problem. When you're trying to complete it using standard algorithm, ask yourself these same questions. And if it helps to do it out loud, do it out loud. How many times does 35 fit into 6? I mean, it doesn't, right? So we put a little mark there to indicate I don't want to put a number in that space. How many times does 35 fit into 65? Mateus? One time. 1 times 35 is 35. Mrs. Finnegan, we should record every day, and they're so quiet. 5 minus 5 is 0, and 6 minus 3 is? 3. Now, 35, does that fit into 30? No. So what do we have to do? Elin?
Drop the 2.
Drop the 2. Let's also keep our decimals aligned, right? So we're going to bring our 2 down. Now, will 35 fit into 302?
Yes.
Right. About how many times? Noah?
8.
8. Noah says 8. So this is what I call back of the envelope math. I'm going to go over to this side, and I'm going to try 35 times 8. 8 times 5 is 40, carry the 4. 8 times 3 is 24, plus 4 is 28. That's pretty close. 280. 8. Now you could decide, I'm not close enough, I'd like to try 9, and you would do another back of the envelope math, but I think 9 might be a little too high, right? So 8 times 35 is 280. 8 times 35 is 280. Subtract. 2 minus 0 is 0. 0, we can't take 8 away from 0, so we borrow. 3 becomes 2. 0 becomes 10. 10 minus 8 is 2. 2 minus 2 is 0. And bring down the 5. How many times does 35 fit into 225? How many times? About how many? Well, it won't fit in 10 times because 10 times 35 is 350. Mateus, do you know?
About like 7 or 6 times.
Okay, 7 or 6. What did you get, Noah?
6.
Let's try 6. Back of the envelope math. 35 times 6. 6 times 5 is 30. Carry the 3. 6 times 3 is 18. 18 is 18 plus 3. 18 is 21. 18 plus 3. 210. I think that's about as close as we can get. So I take the 6. This is going to be the factor that's going to work. 6 times 35 is 210. And subtract. 5 minus 0 is 5. 2 minus 1 is 1. And we are left with this 15. Am I done? Well, the instructions say they want us to take this to the thousandths place. And are we there yet? So we got to go one more space. But I don't have a number big enough to fit 35 into. What can I possibly do? Am I stuck? Am I done? There's nothing I can do. What can I do? Viv? Bring down a 0. You can always add a 0 to this number in the dividend. Does it change its value if you add a 0? No. Oh, it'll never change its value if you add a 0 like that, so don't worry. I'm going to go ahead and try to fit 35 into 150. How many times does 35 fit into 150? Right.
I was just stretching.
Just stretching. Okay, sorry about that. How many times does 35 fit into 150? Nowhere? 4 times. Let's try back of the envelope math for 4. Oops, that doesn't look like 35. 35 times 4. 4 times 5 is 20. Carry the 2. 4 times 3 is 12, plus 2 is 14. Boy, that is close, Noah. Good job. 1, so I look at my factor that's going to work to get me close to 150. 4 times 35 gets me super close. 4 times 35 is 140. If I subtract that, I get a remainder of 10. Now, technically, could I keep going?
Yeah.
Couldn't I just keep annexing more and more zeros?
Yeah.
I could, but the directions say that you only need to take it to the thousandths place. So are we going to be okay with a remainder here?
Yeah.
Yes, we are. We're going to say that our remainder is going to be 10. So remainder 10, and there's our answer. And